All right, 8.3, testing a claim regarding the mean. This should be a short lesson. We have one big idea. We're testing the mean when sigma is unknown. Let me turn down my piazzolla. All right. There is a part 2 to this unit, but we are not covering it because it isn't used often at this point. That is, if sigma, the standard deviation, is known, then the mean should be known as well. So here we go. Key elements. Most of these you should recognize by now. The one that you possibly don't is the population mean. This is the mean based on the mean that is given to us. All right. So it's not the population mean, but it's kind of the claim. Usual requirements, simple random sampling. In this case, we have to have a normal distribution or n is greater than 30. Now in this case, we don't have to be strict with our interpretations of a distribution or n greater than 30. That is, we could have less than each of those and still be okay. So there's a little bit of wiggle room here when we create this particular hypothesis test. Our test stat is based on the t distribution, and that's what it looks like. Okay. We're going to use technology a lot in this particular example. You can use a table. It gets a little bit trickier. Normally we're going to use technology for the p-stat, p-test statistic, or you're going to use the table for the critical values. All right. Don't forget degrees of freedom is n minus 1 when we do this. And a few reminders of that distribution known as the t distribution. As we increase n, n becomes more normal. So as n is smaller, it has a kind of a shorter, wider stance. As n gets larger, it becomes more bell-shaped. The mean is t equals 0, not z equals 0. And our standard deviation is larger than 1. All right, here's our problem. It's adult sleep times. So we have a very small sample, n equals 12, and the average of the data set. In this case, we are given a data set of 12 individuals' sleep hours. And so we have our sample mean and we have our sample standard deviation. We are recommended 7 to 9 hours of sleep as adults. So we're going to use the p-value, and our alpha tolerance is 0.05. Test claim that meant that the mean amount is less than 7 hours. Okay. So that's going to be our test, our claim. We do have simple random sampling. We do have n equals 12, which is less than 30. So now we have to ask ourselves, is the data normally distributed? And here we have two little charts, a histogram, which kind of shows us a bell shape. And then we also have a normal quantile plot, which again shows us a fairly good normal distribution. All right, so there's our claim. Mu is less than 7. So our alternative, mu is greater than or equal to 7. So H sub 0, our null hypothesis, and our alternative hypothesis. There's the significant, and we're after, in this case, the t distribution. And here are the calculations. Notice we are using 7 as our disputed, our claimed mu. And this generates a t-value of negative 0.290. So we're doing a left-tailed analysis here, test. Our p-value, using technology, in this case here, I would, again, use StatCrunch to find this value. A little bit hard to do in the tables. So we use that value in StatCrunch, and come up with that as our p-value. So because our p-value is greater than our tolerance, then we fail to reject the null hypothesis. All right? And we conclude that there is not sufficient evidence to support the claim that the mean amount of sleep is less than 7 hours. Note, p-values are popular to use, and most technology, your graphing calculators, Excel, most stat software will report a p-value. If you don't have access to technology, then we should be using the critical value method, and that is the next example. So, adult, sleep, take 2. Steps 1 to 7, same thing. Step 8. So now we use our degrees of freedom, our t-value of negative 0.290. Alpha is 0.05. That's the area in one tail. And if I look that up in the chart, I'm going to get t equals 1.796. Be careful. We need to switch the signs as this is left-tailed, so our t-value is actually negative 1.796. All right. Step 9, we conclude the same thing. You can see here that our t-value is here and our tolerance is here. Okay. Run that by me one more time, Mr. Larson. Our sample mean is out here, right? And our critical value is here. So there's our negative 0.290. There's our critical value. So we are in what we would say the normal zone, right? We're not in that critical 5%. So that's why we conclude the same thing, that we fail to reject the null hypothesis. And we go on our merry way. Finally, we're going to use one more thing here. We're going to use a confidence interval to confirm the results that we had up there. Okay? Again, that's chapter 7. Take 3, adult sleep. Here we go, one more time. This is a left tail test. Again, our alpha is 0.05, so we use a 90% confidence interval. Remember, always double that, just subtract it from 1, and that gives you the confidence level. So I take n equals 12, and I take my data, and I run to the stuff that we did in chapter 7 to get the confidence interval. You can go to this StatCrunch too and get the confidence interval there, but here we get it. Now notice, yeah, that limit, less than 7. This limit, not so much. So because both limits are not below, then we cannot reject our null hypothesis. Okay, ending with the same conclusion. Hopefully that makes sense, and you're able to zip through those homework assignments. And I did have one question on 8.2 I've got to get back to. Reed had a difficulty with one problem I'm still working on. Good luck.